So I would like to say that I'm very grateful for the invitation to talk here at Beijing Language and Culture University. Those of you who have attended my earlier lectures know that I have got a bit of a cold, so excuse me if I cough from time to time. The topic of this talk is concept, context, and extended embodiment, spatial language and cognitive development. And it continues the theme of the lecture this morning, in that it is about space, the language of space, and about cognitive development and language acquisition. And it is also about the comparative study of development and acquisition. Let's start with a quote from Benjamin Lee Whorf about spatial conceptualization and language across languages. Whorf says, the concept of space will vary... Can you still hear me all right? Is that okay? That's better for me. The concept of space will vary somewhat with language as an intellectual tool, which is linguistically conditioned. In other words, Whorf considered that space was one of those cognitive and conceptual domains which would be affected by his linguistic relativity mechanism. Here's an outline, and of course what we're going to do is we're going to see whether or not this is true and whether we can detect such relativity effects in early cognitive development and language acquisition. Here's an outline of the talk. I will start by talking about spatial understanding in infancy. As I mentioned this morning, cognitive development does precede the acquisition of language, so we shall look at cognitive development in spatial understanding in pre-linguistic infants. First of all, we'll talk about the legacy of Piaget. We will ask the question, do infants have concepts of space? I mean pre-linguistic infants. And we will ask the question, is space a distinct domain when we examine it from the point of view of cognitive development? And then we'll go on to present a study of the development of early spatial concepts and language in a cross-cultural and cross-linguistic perspective. Piaget is, of course, a giant figure in developmental psychology and theories of cognitive development, so we shall spend a little time looking at what Piaget said about spatial understanding. In general, his theory posited a developmental progression from sensory-motor understanding to conceptual representation involving a relatively late emergence of concepts proper. In fact, for Piaget, the emergence of concepts, proper concepts, was effectively coterminous with the emergence of what he called the semiotic or symbolic function, which occurred around about, well, in the second half of the second year of life, so by around 2 years of age. And for Piaget, it's important to note that cognitive development is not something which is domain-specific. In fact, he believed that development integrated domains in global stages of development, which were based upon the organization and coordination of action, which was the principal key theoretical notion in Piagetian psychology. He also believed that cognitive development was an epigenetic process. And I have to say that the importance which I accord to epigenesis as a developmental process, and which I have talked about and will talk about more in subsequent lectures, is something that I have taken from Piaget. Although I'm not quite such a universalist as him. But nonetheless, he believed that not only was epigenesis a universal process, but that the products of epigenetic development were also universal. He believed that cognitive development was a universal process across all children from all human cultures. And finally, he believed in the priority of cognition over language. Cognition leads language for Piaget. Piaget is for Piaget, the acquisition of language is a consequence of and a manifestation of cognitive development rather than the other way around. So, if we ask the question, do infants have concepts of space? This is what Piaget says. The development of the concept of the object implies a sensory-motor representation of spatial location. For Piaget, a key milestone in cognitive development is the attainment of the concept of object permanence, that objects continue to exist even when they are out of sight or when their location is changed. So the development of the object concept implies the first representation of the coordination between object and its location. He also believed that representational understanding, which would be something like the notion of concept, does not emerge until mastery of the object concept itself is complete at around about 18 months. And it is this emergence in the second half of the second year of life that heralds the emergence of the semiotic function. He also believed that there is a universal developmental sequence from topological to projective spatial representations, and that this is reflected in early language. Now, those of you who were here for or who were at Beihang University for my lecture this morning will know that actually the data that I presented from our studies on English, Danish, and Japanese are absolutely consistent with this last part of Piaget's hypothesis. However, more recently, researchers have questioned some aspects of Piaget's account, and in particular, they've suggested that there is an early understanding of space before Piaget believed to be the case, that is, earlier in infancy. More recent research views spatial cognition not just as part of the object concept, but as part of event structure cognition, infants' understanding of the way that, as it were, things happen in the world. And instead of Piaget's tasks, which involve the active motor engagement of the infant in the experimental situation, they use experimental paradigms such as habituation, dishabituation, violation of expectation, and preferential looking, all of which situate the infant as an observer. And it is claimed that an advantage of this kind of task is that it does not require the child to have a high level of motor coordination. Instead, the infant can just register as an observer things that are happening in the world. Other people actually question the utility of these methods, saying that, in fact, they also introduce distortions, but we won't go into this technical issue. We'll just look at the results that have been found. All of these paradigms employ as an experimental variable the length of gaze that the infant focuses on an event or an aspect of an event as their experimental variable. A lot of work has gone into the relationship between, as it were, spatial understanding and infants' understanding of motion. Infants begin to display expectations about motion events in the physical world from 12 weeks of age or less. One of the earliest responses that infants have is the avoidance of looming objects which appear to be coming towards them in space, getting bigger as they move towards the line of sight of the infant. And infants try to avoid this, and they show from their physiological reactions that they perceive this motion. But also, they track the path of a moving object, even when its path of motion is invisible. So, for example, if an object is moving and the motion takes it behind another object which is occluding it, a screen or something like that, infants are not surprised when the object appears on the other side of the occluder. That suggests that they're expecting the object to reappear. But they are surprised if the object does reappear but in the wrong place. That suggests that they've got quite a good idea of an elementary notion of the path of motion. And of course, path of motion is a fundamental constituent of the semantics of spatial motion. We can also look at studies of infants' understanding of containment and its relationship to occlusion or hiding. Infants of 3.5 months understand that when one object occludes or hides another, whether the occluded object completely or partially disappears depends upon the relative heights of the objects. So they understand something about the relationship between the different sizes of objects and whether or not one object will then hide another object in space. Also, they can distinguish between occlusion, that is just hiding behind, and containment from about 4.5 months. And they can reason about height in occlusion from 4.5 months, but not until 7.5 months in containment events. That suggests that containment is a rather more complicated relationship to understand, and that perhaps the earliest age at which we can suggest that it is there is from 7.5 months or so. What kind of understanding do infants have of these fundamental concepts of support and containment, which we saw this morning, are actually present very early on in the language of the productive language of children acquiring Danish, English, and Japanese. As young as 4.5 months, it seems that infants can distinguish between possible and impossible support events and are surprised at impossible ones. And by 6.5 months, they seem even to understand that balance plays a role in support against gravity. At 9 months of age, infants understand that upright containers were more likely to take their contents with them when they're displaced than inverted containers when tested using the infant search paradigm. That's some work that that some colleagues and myself carried out many years ago, as a matter of fact. So that's very simple. If we take a container, if the container is upright and I move it, yeah, then whatever it's containing will go with it. But if I was foolish enough to turn this upside down, all the tea would spill out of it, and it would no longer carry its contents with it when it moves from one place to another. And it seems that infants of 9 months of age do understand that and this was a task which didn't use preferential looking. It actually did involve children's or infants' motor responses. So, let's try to sum this stuff up. Do infants have spatial concepts? Most of the experiments referred to above, or at least a good number of them, involve an understanding that goes beyond perception, implying a level of spatial representation. This is a tricky one, and I've already devoted one lecture to exploring the notion of representation. Here I'm talking not about conceptualization as such. I'm not talking about linguistic representations. I'm just talking about what we might call psychological representation. So I'm not claiming fully blown concepts or anything like that, but it does seem to involve categorizations which go beyond immediate perception of the single situation, and it involves the ability to make some kind of perceptual predictions. And this is consistent also with findings in other domains such as object categorization, particularly in the work of Jean Mandler, who has been probably the most important developmental psychologist looking at the development of categorization relevant to the kind of things that cognitive linguists are interested in terms of image schemas and so on. However, this understanding so far, as we've taken it up to about 9 months of age, is context specific. It's not yet fully generalized by any means. And the other thing is that it's linked to other aspects of what we might call causal event cognition. These very early understandings of, for example, containment, are not understandings of a concept of spatial containment which is separate from and different from the schematization of motion events, for example. It's all part of one kind of global thing. And so we can actually say that spatial understanding can also mislead infants and give rise to errors in predicting the nature of events and organizing actions. So, for example, their understanding that an inverted container is not a good container and that it doesn't take its contents with them will actually mislead them, even if the container is resting on a surface and the object is underneath it, in which case it will take it with it. They don't understand that. So this is not a highly differentiated set of spatial concepts. It's all very much part of an emerging system of understanding which is something more than just perception and something less than autonomous concepts. Now this leads us to another rather important question. A lot of modular theories of language acquisition and development, and often such modular theories go together with nativism, suppose that infant development consists of development in very specific and distinct cognitive domains, of which, for example, space would be one. And the question is, and also, if you think about it, when we talk about as we are doing today and have been doing this morning, when we talk about the cognitive semantics of space, we make exactly this presupposition, that there is a thing called space, whatever that thing is, you know. I mean, of course, it's not a thingy kind of thing. It's a rather abstract domain. But nonetheless, we do consider space, for example, to be a domain which is distinct from the domain of objects, and so on. Is space a distinct cognitive domain for infants as well? Well, I'm not sure about this. And in fact, I'm skeptical about it, because spatial notions, it seems, for infants are integrated, and indeed sometimes inappropriately integrated, with other aspects of event cognition. Also, spatial notions do not emerge simultaneously, and from what we've just looked at, there is some evidence that motion and gravity have priority. And maybe there's a good reason for this. Motion and gravity have a high degree of perceptual salience in the infant's world. If you drop an object, it falls. If the infant itself is trying to get up and falls over, it's under the influence of gravity. And motion, of course, is of fundamental importance, not just objects moving out there in the world, but the infant itself being carried around by adults. So all of this makes sense from an experiential point of view. So I would say that the evidence is consistent with the existence of innate predispositions for forming spatial representations, but much less so with the hypothesis of a unified spatial cognition module. So what does this tell us about cognition and spatial language acquisition? Or rather, what kind of hypotheses might we form on the basis of this? And I'll come back to some points that were made this morning as well. We have seen that pre-linguistic infants have already constructed cognitive representations, which maybe we ought to call proto-concepts, and that's the term that I will use, proto-concepts. Jean Mandler thinks that pre-linguistic infants really have concepts. I'm not so sure about this, because I think that true concepts require language. But anyway, let's call them proto-concepts of spatial relations such as occlusion, support, and containment. And if this is so, this can give rise to the cognition hypothesis, which I already raised this morning. And the cognition hypothesis is we are able to understand, well, by we, he means, you know, language acquiring and developing children. We are able to understand and productively to use particular linguistic structures only when our cognitive abilities enable us to do so. And that's the cognition hypothesis as formulated by Rick Kromer as long ago as 1974. The version that I gave you is a relatively weak version. It's just about readiness. You know, when you attain a certain readiness, you'll acquire for the language. Through your cognitive development, you will acquire the relevant language. You can also make a stronger version of the cognition hypothesis, which would be as follows. The process and content of early spatial semantic development, we're into language now, is determined by universal pre- and non-linguistic perceptual and cognitive processes and structures. That would be the strong version of the cognition hypothesis. Against this, we have to set the fact that languages vary very widely in the particular ways in which they semantically organize space, which we did see this morning, right? And this is rather dramatically so when we compare English prepositions with, for example, Japanese postpositions, or as we shall do today, this afternoon, with body part locative languages. And then we can ask ourselves, what consequences might this have for language acquisition patterns? So here we have two hypotheses on cognition and early spatial language acquisition. Firstly, the cognition hypothesis predicts that children map spatial relational words to universal pre-existing spatial concepts. Since languages vary so much in their semantics, this should give rise to many and predictable errors. Whereas the language-specific acquisition hypothesis predicts that children should pay attention to usage in the language that they are acquiring, changing their pre-linguistic cognition in the direction of the semantics and making fewer errors. Now, for the benefit of those of you who were not at the lecture this morning, I should say that the data from our work on productive acquisition of spatial language in English, Danish, and Japanese was consistent with a two-stage or two-phase developmental process, the first of which was consistent with and perhaps governed by the cognition hypothesis, and the second of which was much more consistent with the language-specific acquisition hypothesis. And what we found was that the first around about 6 to 8 items in the lexical repertoire seemed to be very similar as the cognition in terms of meaning as the cognition hypothesis would predict, but that after that children followed developmental pathways which were much more governed by the structure of the language. But that was a study of production only, and today we're going to look at a study of comprehension and a study which tries to get much more directly at the underlying conceptualizations that the children are acquiring. So I'm going to present some data from a comparative study of cognitive and language development in the languages Danish, Zapotec, conducted by Christine Jensen de Lopez, who was my PhD student. In which we actually found significant differences in performance between the two groups, Zapotec and Danish, motivated by the semantics of the two languages in both linguistic and non-linguistic tasks. Now, I have to explain to you something about these two languages. You probably will already know something about Danish, and it's very likely that you know almost nothing about Zapotec. They're two very different languages and cultures. Danish is a Germanic language spoken in Northwest Europe. It's a Western, in inverted commas, because the notion of Western, by the way, no longer has much to do with geography. If you want to know which of these languages geographically is more Western, geographically it's Zapotec. But the term Western in terms of descriptions of culture, in terms of geopolitical discussions and so on, is a kind of a metaphor, or well, actually a metonym for a whole cluster of attributes. Let's not go into this in detail. So it's a so-called Western industrialized society with many canonically unifunctional artifacts. What I mean is the material culture in Danish society, like the material culture in British society and Chinese society, is highly variegated. Being a technological society, it has many artifacts which are used for one specific purpose. It has a high degree of division of labor with a predominance of non-manual labor, and linguistically, prepositions are the principal linguistic means for expressing spatial relations. Zapotec is, strictly speaking, Zapotec is not a language, but a branch of a language family or a subfamily. And the family would be Otomanguean. A group of Otomanguean languages spoken in southern Mexico, which can be characterized as it were, a non-Western agrarian society, a non-industrial society. Yeah, it's an indigenous culture and language of Central America, and Zapotec society is one in which there are relatively few artifacts which tend to be multifunctional. The things that people make as tools, they tend to use for more purposes than one. And you know, from your knowledge of your own society and culture and the distinction between agrarian and urban ways of life, you will know that in urban ways of life, there are many more artifacts employed, and they tend to be much more specialized. In agrarian ways of life, fewer artifacts are used, and they tend to have, each one tends to have more than one function. It's a generalization. In Zapotec society, the human body is both the principal instrument of labor, so manual labor is dominant, and it's a culturally salient semantic source domain. Because Zapotec is a body part language, which uses body part locatives as the principal linguistic means for expressing spatial relations. So how does that work? It means that they take, just as we in English use body part terms to conceptualize spatial relations in expressions such as the mouth of the river or the foot of the mountain. You find this in Zapotec, but actually what they've done in Zapotec is that they've completely regularized this and grammaticalized it, so that's the way that you do it for all spatial relationships. So that, for example, in English we say, the cup is on the table. In Zapotec they will say, the cup has faced the table, because these body part terms have become grammaticalized into effectively just about prepositions. I think you can really say they are prepositions. So let's have a look at this system. These are the Zapotec body part locatives. They are regularly, productively, and obligatorily used to express location. You have to use body part locatives. Lexically, the body part locative is identical to the body part noun, okay? So that's like saying there is no difference between the word. If I say the cup is faced the table, it's the same word as the word for the body part, the face. They are preposed to the landmark NP. They're prepositions, basically. And they're at an advanced stage on a grammaticalization path to being prepositions with morphological reduction and constructional change. I think they're just about are prepositions. And in this particular variety of Zapotec, which Jensen de Lopez studied, which is San Marcos Clapazola, which is a variety of Valley Zapotec, the principal body part locatives are the following 7, which can be glossed in terms of the English words head, face, mouth, stomach, back, bottom, and foot. So just a couple of notes about that. Stomach is the general expression for containment, and bottom is derived from that part of the anatomy. the bum. And body part locative usage is based upon the metaphorical projection of the human body schema in canonical orientation. In other words, the human body standing upright onto physical objects, and it's modulated by pragmatic functional considerations. The first person to actually describe this system was Robert McClory in an article in 1989. And by the way, it's worth noting that the use of these body part locatives is not only for contact situations. So, for example, if a bird is nesting at the top of a tree, okay, you say that the bird is head the tree. But if the bird is flying over the tree, you also say the bird is head the tree, yeah, because there's a kind of zone of a spatial regional zone which is projected from that part of the object. Okay, so you've got a metaphoric projection of an entire body schema onto the object, and that schema then gives rise to various kinds of zones or regions which are also conceptualized using that body part term, the relevant body part term. Examples. I'm not going to try and read the Zapotec language. If there's a chicken on the roof of a house, you say chicken head house. If the chicken's in front of the house, you say chicken face house. If the chicken's behind the house, you say chicken back house. If the chicken's in the window or the doorway of the house, you say chicken mouth house. If the chicken's inside the house, you say chicken stomach house. And if the chicken's on the table, you say chicken face table. And that could also be the case for the chicken in front of the table. So actually, once you see it, it looks pretty logical, right? I mean, it works in the way that you would expect it to work. And just a note here, related to something that I said this morning about human and non-human body part locative schemas. There is a closely related language or language group called Mixtec from the same region of Mexico. Mixtec also uses body part locatives, but their schema is based on that of an animal, not a human. And Lakoff talks about that in his book, Women, Fire and Dangerous Things. Talks about Mixtec. Oops. Relevant for us is the comparison between the English and the Zapotec containment schemas. In English, if we view this as a container which is it could be of indeterminate size, could be either something the size of a cup or a basket, or it could be something bigger like a house or dwelling. In English, well, in English, if it's a relatively small thing, let's put it this way, if it's like a basket, then this is expressed as an in relationship, and this is expressed as an under relationship. In fact, as the thing gets bigger in English, if it really gets to the size of a house, this could also be an in English. But for small objects, this one on the right is an under relationship. Whereas in Zapotec, they pay no attention to the orientation of the container, as it were, and both of them are called stomach. Both of them are expressed by the term stomach. So what we did some experiments with young children, comparing Danish and Zapotec children doing exactly the same things. And these experiments were actually based upon some experiments that I'd carried out in English some years previously. And as we go on, everything that I say about the way that the Danish children responded, you can also take to be representative of the way that English children in earlier experiments responded as well. And the two kinds of experiment were, one was a linguistic experiment, and the other one was completely non-linguistic. The non-linguistic experiment was an action imitation experiment in which the young child of around about 2 years of age was required to imitate an action resulting in a particular spatial configuration. And the objects that we used were little grains of corn and small baskets. So in the action imitation task, the experimenter had a basket and a grain of corn, and put the corn either in, on, or under an upright or inverted basket. And then the child had identical objects, and they had to imitate the action of the experimenter, yeah, with their own basket and grain of corn. In the language comprehension task, only the child had a basket and a grain of corn, and they were asked to carry out an instruction to bring about the spatial configuration, to put the grain of corn in, on, or under the basket. And of course, for the Zapotec, the words in, on, and under were not used, but the words head, stomach, and foot were used, okay? Now, so there's the baskets in upright and inverted orientations. This is placing the corn inside the basket, on top of the basket, and under the basket, okay? Now let's analyze the results that we obtained from this experiment. The spatial configuration produced by each child for each trial was etically coded. In other words, the actual end state which the child produced, either in the action imitation task or in the language comprehension task, was coded independently of the semantics of either language. Yeah? And then response type frequencies were counted and compared across conditions and languages. This gives you a breakdown of the participants or subjects by age and language group. You can see that there were more Danish than Zapotec kids. It was quite difficult to get kids, enough kids in the village, so the number of Danish participants was higher. And they were not so well balanced between male and female in the Zapotec sample. And these were the age groups. Children between 17 and 24 months, between 25 and 35 months, and between 36 and 46 months. So we can safely say these were not pre-linguistic infants, they were language-acquiring children, okay, from the second half of the first year of life, of the second year of life onwards. And here is a breakdown, which is, of course, quite difficult to follow in this tabulated version. These were the responses as they were coded all together. And you can see immediately that if we take the inside response, yeah, that the child, whatever the actual instruction was, okay, in the language comprehension task, the number of responses in which the child put the grain of corn inside the basket was much higher than any of the other responses. And in fact, given the design of the experiment, they should have had the same number of inside, on top of, and under responses, but they went more inside, more on top, fewer on top, and then even fewer under. Okay? So they had a bias towards inside. What about the Zapotec kids? That bias was not there. You will see that 45, 47, 27, there's not very much difference. Of course, we have to analyze that statistically. But before we do that, that's what you get in the language comprehension task. Now let's look at what you get in the action imitation task, where the child is just imitating an action on the part of an adult without any use of spatial language. Okay, no prepositions in Danish, no body part terms in Zapotec, only the request to do what I did, okay? And incidentally, this is a really great methodology because you'd be surprised how willing little children are to imitate your actions. They love it. They really are very happy to do this. And what we find here is in the Danish case, we still have a preponderance of inside responses, which is not the case for the Zapotec kids. Now what I've done next, in table 4, I don't know why that's table 4, because no, it is table 4, yeah, that's right. Is broken these down into the 4 main response types, in responses, on responses, and under responses. So like placing the grain of corn inside, on top of, or underneath the basket, and then put everything else that the children did as other responses, okay, including when they didn't respond at all. And I've broken this down into the action. I've put in the same table action imitation and language comprehension tasks in both Danish and Zapotec. And here what we see is that in the Danish case, from the percentages, the in responses are higher than the on responses, which are higher than the under responses in action imitation and in language comprehension, and that is not the case for the Zapotec children. And is this statistically significant? Well, it is. The percentage is less, or the probability is less than 0.05, which is statistically significant for the action imitation task, and less than 0.02, which is statistically significant for the language comprehension task. And that means, very simply, the two groups of children are not behaving the same way. And they're not behaving the same way in a language comprehension task, and they're also not behaving in the same way in an action imitation task. And I've shown you the numbers, and here we can sort of graph it. Well, I think that these ones are the Danish responses, and the gold ones are the Zapotec ones, but it's not showing up on the right here. And you can see this pattern in the Danish children and a different pattern in the Zapotec children. Of course, the absolute numbers for the Zapotec children are lower because there were fewer of them. And that was the language comprehension, and this is the action imitation. you can see the same shape of graph in the linguistic task and the non-linguistic task. Yeah, is that clear? The same shape of graph. And Danish, Danish is the bluish one, and Zapotec the gold one. Right. What do these results mean? The two language groups differed significantly in their response patterns on both tasks. These differences were parallel across tasks, across the language task and the non-linguistic task. The patterns for each group, the Danish and the Zapotec, on the linguistic and the non-linguistic tasks resembled each other and differed from the patterns of the other group. The Danish children showed a in greater than on greater than under frequency pattern, which we can call an in preference or canonicality effect. Why do we call it a canonicality effect? Because if you take a container, such as a cup, or in this case, a basket, the canonical orientation of the cup or basket is upright, and its canonical function is to contain things. Do you agree? Yeah? So the canonical or socially standard orientation and function is one which would lead you to an inside response. And that's what the Danish children do. And when we, in an earlier set of experiments, did exactly this with English children, except using cups and not baskets, we got exactly the same effect, a canonicality effect, which tells us something. It tells us that these children's representations of spatial relations are bound up with and related to their understanding of object function and use and the social norms governing their orientation. The Zapotec children showed no such pattern or effect. In effect, they were just as happy to put the grain of corn inside, on top of, or under the basket. These differences were not simply due to relative frequencies of correct versus incorrect responses. Both groups made erroneous placements, and there was no overall performance superiority for either group. So it's not like that one group is doing it better than the other. That doesn't account for these findings. Why? Why is this? Now, the differences between the groups on the language comprehension task, where the children are asked to make a placement of the grain of corn, can be accounted for by the language-specific acquisition hypothesis. It could be that in English, they're being diverted by, in Danish, they're being diverted by the object function of the basket as a container, their knowledge of that basket, which is leading them to make this pattern of errors. Whereas in Zapotec, which doesn't, as it were, profile anything except the, in which terms like in are not associated with canonical containment, but just with the kind of, the actual part of the object under its metaphoric schematization as a human body. You could say that the children are not actually being misled by the object properties, and therefore their response patterns are much more evenly distributed amongst the different required end states. And this would be consistent with Jensen de Lopez's longitudinal production data, which I'm not talking about this afternoon, in which she found, perhaps not surprisingly, that Zapotec children used the body part terms appropriately and correctly, more or less right from the start, with very few overextensions, which is also consistent with what we found for the Danish, English, and Japanese production. So, the language-specific acquisition hypothesis can account for the language comprehension data, but it doesn't account for the differences on the action imitation task, in which there was no linguistic instruction, in which the instruction was basically just do what I do, imitate what I'm doing. How do we account for that? To explain the difference in performance on the non-linguistic task, we could appeal to a Whorfian effect. We could suggest that the language that the children speak or are learning to speak is already affecting their non-linguistic representations or conceptions of the world. But is this really plausible at such a young age, when they're really only just acquiring language? An alternative explanation examines cultural practices using baskets as containers and covers. And this is what Jensen de Lopez found in her informal ethnographic observations of life in this village. And this is a quote from an article that we wrote about this. The Zapotec culture makes use of a smaller variety of artifacts than the Danish culture and tends to employ them flexibly and multifunctionally. In the village where the Zapotec study was conducted, baskets are commonly used in inverted orientation, and we put inverted there in inverted commas, because from our point of view, it's an inverted basket, but maybe from their point of view, it's just as much upright as the other way around, yeah? Baskets are commonly used in inverted orientation as covers for tortillas, which are kind of maize or corn flour pancakes, and other food items. And also, they're stacked for storage in inverted orientation. Yeah, so they're stacked as a kind of a cone, one on top of another. These baskets are also frequently used in inverted orientation in children's games, for example, in catching chickens. Inverted baskets are sometimes placed over brooding chickens in order to keep them on their eggs so that the eggs will hatch. If the Zapotec containment schema was constrained by the landmark of the location of the trajector, it would seem that in this culture at least, the schema is not canonically associated with an orientation of the container with its cavity upwards. So maybe these findings tell us something not just about the language, but about the relationship between language and cultural practice and the meaning of objects. At least that's our hypothesis. So here is my conclusion. Objects and spatial relations are not just physical, but also sociocultural objects and relations. Biologically based spatial cognition, which maybe does begin with certain innate readinesses of the human infant, is embedded in, interwoven, culturally specific, non-linguistic and linguistic practices. It is through their participation in such practices that children gain mastery of culturally and linguistically appropriate spatial cognition. And this takes us beyond the kind of linguistic relativity theory proposed by Worf. Both express and entrench cultural variations in universally constrained patterns of thinking. So I end with a quote from Gary Palmer from his book, Towards the Cultural Linguistics. Language both expresses and constitutes worldview, but could only fully determine it in a culture that lacked other means of expression and communication. And amongst those other means of expression and communication are simply the artifacts of everyday life and the cultural practices surrounding those artifacts of everyday life, the objects that have meaning within cultural formations and cultural practices. Thank you.